All right. Sorry for this. Let's do like that. There was not many people on campus, so it was mostly I don't know some other students in that lab. So I thought it would be easier if I just focus on this and I try to record this at the same time, so we have it for reference. So today is the introduction to scaling web apps. It's continuation of what you did in assignment 2 and something that is then a requirement for the group project. And also this is the whole point of Kubernetes in the in the first place. So it would be very bad if we miss that part of the course. So that's what Kubernetes is for, scaling. So, what scaling features do we have? There are three different types of scaling. The first one is horizontal scaling, which means basically when you create a deployment, it can scale over different pods. Vertical scaling is when you can have more resources like CPU or memory. And finally, cluster scaling, when you create more worker nodes, more replicas, and in some cases, even more uh, cluster resources dynamically also. Some of these things are not available when we do this in our mini, mini version of Kubernetes on CS Cloud, but it's still something that is good to know. And if you, maybe some of you will test a different provider. Let's see here. Uh, you are in somewhere in, yeah, they write that they are in a different room. Difficult to know, but I can come there later. Let's see here. Yeah, so some of these features are not possible in CS Cloud setup, but they're still good to know, and they are available if you, for instance, are gonna try Google Cloud or Amazon Web Services, which is also an option for a group project if you decide to go for that. Then the resources there will also be limited if you're only using free tier, but you still can try it to a certain extent. But what we are going to focus on then is what is available to us is horizontal scaling, so creating more replicas and more pods. It's very important now at this stage to also distinguish what is a replica, what is a pod, and what is deployment. So read again the literature or on Kubernetes IO. And here is like a simple illustration. So with the replica set is, in our case, a deployment, which can consist of several pods. It is probably corresponds to a container in the Kubernetes environment. If in TaskKit in the default, all of the microservices were deployed with one replica. You specify it in the deployment file in the YAML format. However, in real life, we probably need at least two replicas. Why is that? Is because pods, they are short-lived. There's a lot of things that influences replica set. If scaling didn't go as expected, if there are problems with the cloud, they can be terminated. If you configured, if some configuration changes and someone tries to contact, there's some error. Anyway, they can all be destroyed, and that means downtime for your application. So replica in this case saves you from that. You always have at least one copy that is available. One copy of your microservice or the app, right? So one of the requirements then for the group project is to, at least for one microservice, try deploying over several replicas and make sure that it still works as expected and that you have tried it, right? Otherwise, we're going to focus on the pod autoscaler feature, which means that depending on how many requests your microservice is getting, it can automatically scale to more instances within this replica set. And then you probably still haven't tried on TaskIt. If you haven't done that, then you can already now try it on if you save that deployment you can enable auto scaling manually. So like just go to the jump host and run a command like that. One thing is that to make sure that you have enough resources. Maybe you don't have too many other things running. Then otherwise it might not work at all, right? But it's as easy as that, and you can in the same way just enable it in the YAML file. So min amount of pods and max amount of pods, and then Kubernetes will magically scale it to to whatever is needed, and will not run more pods than necessary either. So that's something worth to try even on your Tasket deployment before you move on to the group projects, just to get a feel for it. Mats has also been working on an instance of the Terraform scripts, which allows you to dynamically to change the specification of the nodes in CS Cloud that that are running your apps, because the ones that are now, they're by default, they're very slimmed down. There's not so many. I think there are 2 CPUs and like very limited memory. So that will also very quickly run out if you try to scale anything. So you probably need to need more resources. Then how do we make sure then that this horizontal auto scaling works? There is a very good guide on Kubernetes IO, horizontal pod autoscale walkthrough. You will get this guide. Again, this is like a way to play with scaling on Kubernetes just with the commands. So we need to like log SSH to jump host and try this commands, like see how the amount of pods changing. Make sure that you see some that you have enough resources and so on. So again, you can test it on any like simple app, either Hello World app that you deployed together in the group project, or the Tasket that you already have. So just to get started and get a feel for it. Then for actual testing in production and like in the real environment, load testing is performed with either external services. They're mainly like if you just Google load testing, there are tons of usually paid and pretty expensive resources, because it does, to create load onto application, you do need resources as well. So one of the sort of free solutions that you can do is you can write your own scripts that also either run on your cloud as well, or even on your local machine. So we don't need to create 10,000 users to be able to see that the application scales. We can just have like 20, 100 requests and already see some movement. So that's the goal. So Locust is a Python library which lets you basically run a web server that does load testing. You can create like this type of load requests. So like you go like, I want to put load on the tasks endpoint. I want this many requests, blah, blah, blah. So without code as well. Or you can specify the tests by writing Python scripts. So whichever is good. You can also, if you don't like this for some reason, there probably some JavaScript library, or you can just write a simple script yourself. But I suggest that you at least one test. It doesn't have to be included in your continuous integration pipeline, but I want to see it in the submission in some way, that you have performed a load test on one of your microservices and you saw that it scales and maybe even fails at a certain amount of requests. Now I'm out of resources, the app is down. So that's the goal. But to see that what is happening, you need some types of metrics and monitoring. Initially, I thought like, well, there is Kubernetes dashboard. There is a feature in Kubernetes that lets you use dashboard. If you Google it, it's a pretty nice service. It starts up as a as a full-blown web app in your Kubernetes cluster. You can see fancy graphs. You can follow how the pods are scaling and how the instances are created. If something is wrong, it can send you alerts, blah, blah, blah. Unfortunately, so far I haven't managed to make it work with our current installation of Kubernetes. So that might be either an issue with the proxy, because you need to make it publicly available, you need to log in with a token, which goes like, which is hidden with behind HTTPS, and the token is generated in some weird way, so it doesn't. I haven't managed to make it work on CS Cloud, but you can easily try it on your Minikube installation, which is also a pretty good start if you want to understand and get like a visual representation of all these things. For Minikube, you just run basically this as a Minikube enable dashboard, and it will say I'm running now on localhost at this port, so you can access it and see. So that is also perfectly perfectly good start. However, for CS Cloud, then I suggest trying this K9 IO, K9s. This is basically, you can say, terminal-based dashboard. So no fancy installations needed. I think you can install it with Helm, if I'm mistaken. So you can just go on your jump host and make it available, and you have tons of commands, and you can see all your services, how many restarts it was, how much CPU it's using, and also for Mongo instances. So then if you put load on it at the same time, you will be able to see the difference. I will provide like a README file, a guide that lets you kind of experiment with this and perform this type of load test that is needed. It is also you can of course do like follow monitoring with like regular metrics server. So you need to just enable that feature in kubectl, and there's also a bunch of commands that let you follow your pods. So this is what is used here, for example, in the test your HPA walkthrough. That's what they're using in this guide as well. There are no external tools except the metrics server. Then in the real life setup, you'll probably also have a more advanced dashboard to monitor your cluster. It's usually is either Grafana or Prometheus. If you look at like the job postings that requires like backend web backend or some kind of data engineering positions, that's always you will see either Prometheus or Grafana as one of the skills along with Kubernetes. So that is not the requirement in any way for the group project, but it's a nice bonus if you have time and want to come in touch with like real world tools, is just to make it available. And for Grafana, at least, you can Dockerize it and run it in your cluster as well. You just need to forward the data from the metrics server, and you will be able to create fancy graphs of your scaling. So this is like creativity of time sets the limit, but I think it's really important that it's in a very minimal way. You can see, okay, if I put so many requests on this endpoint in one of my microservices, it scales to this many pods. Or then if I turn down the load, it auto scales down, and my functionality of the app is working unaffected. So that was it about the HPA. Then there were a lot of questions about data management, and I see that it might not be super clear what we're doing with the database. And here again, there's a whole big chapter in course literature on data management, and there are tons of different patterns. You can probably have a separate course on data management in large scale data intensive applications. We're not going to do that. we're going to do a simple version of it. But the mini requirement is that you implement some type of data management strategy that is relevant for your application. Now, for the liter application, that was case in previous years, which was only the one group project that's available. It was discussed that the read load, so the amount of requests for reading from the database, or in that case, reading those lits, right, the posts, was much higher than the write. So that's why the command and query responsibility segregation pattern is relevant for liter. That might not be relevant for another app that you're implementing, might not be at all relevant. So there could be other things that you need to consider on the description of the assignment and what needs to be included in the, I think, in the non-functional requirements. I put like some suggestions of what you can pick, so that one of the things for the report one is to pick your data management strategy and motivate why. Right, so in the command and the SQRS pattern can also be implemented in different ways. So the classic one that's described here is that you actually have a different database, one for all the reading applications, right? And then there is some kind of API that manages that. For one for writing and one for reading. So this is the classic pattern, and then there needs to be some kind of potentially some kind of communication between them to sync maybe some relationships or something. Or it's not necessary that that's the case. They might be completely separate as well. So I actually personally haven't seen this as much in the applications that I have been part of. What is much more common is this. So you segregate microservice and you segregate the database with it. And that in that case, the data management comes, the decoupling of it and the distribution of load comes based on functionality as well. So like let's say that in many of the apps that you're going to implement, we often separate the user handling and the actual logic of the app. So then the hope then is that, yeah, there is the load for creating users and updating profiles is separate for the load of the main logic. So there is no need to access the user database if it's not needed. But in some ways, for instance, like if you say you have some of you implementing games, and then that requires getting user information at the same time as you create a game. So that's something to consider. Do these microservices need to share a database in some way? And in that case, can I use SQRS pattern but with a different implementation? If you're using Mongo, for instance, you have both data sharding that's easily enabled with the MongoDB features, as we already discussed in, some of you already used this in VT2, right? So this is one thing, like there are different types of separating the data within MongoDB. And there are also so-called read replicas. So when you deploy Mongo on Kubernetes, you can specify that it needs to scale over different replicas, and some replicas will be used only for reading queries. So in that sense, you will implement SQRS without actually making a separate database, and it can still be shared between different microservices. So all of this are okay. It is also might be relevant for some of you implementing a data service, or if you call it like API gateway, whatever, some kind of service that handles requests from different microservices and manages access to the database, which you, in this case, you will probably scale this microservice horizontally so it can handle all the requests in between. So these are some suggestions, whichever works, as long as it's motivated that that's what you think is needed for your app. And yeah, as long as it also works functionally and you manage to set it up in your deployment. What is not okay is just having one one Mongo that is not using any scaling features. So that would not be okay. So some kind of for big nut is needed, but we still keep it pretty simple, as I said, because I don't think we have time to go in detail, especially like event-driven architectures that the data management can be much more complex. You'll probably have an event bus, you will have a synchronous data replication and asynchronous updates and all that. So we keep it simple. I think we have enough to worry about with Kubernetes and VPN. So that was it. I'm gonna stop recording now if I can. Let's see here. How do I stop record? Pause now. Eller? Oh my God. Me and recording on Zoom. How the hell do I do this? The screen sharing is paused. Let's see here if I stop sharing.